Thank you, JC. I feel for you guys, sadly, and sadly for me, I'm not the Josh Allen, but I am Joshua Allen. For me, I'm the director of marketing here at Harpak Oma. I've also taught over 15 years at Boston College. So the reason why Spencer and I are presenting together is we're going to hope to give a lens into a new way to think about automation within the manufacturing space from both a technical standpoint, which Spencer Thomas, our application engineer, will dive into, but also from a human, organizational, people lens, which is where my academic background comes in. So I'm going to take the first part of this and really try to give an overview into some of the labor pressures that become kind of a catalyst for thinking a little bit differently of what automation can be within our processes. And then we'll dive into some of the actual applications that Spencer lives, breathes, and brings to life. So some of these facts that you see up on the screen within the slide decks are data points that we pull up to make a case. But I would argue most of our customers don't just see them as data points, they feel them as real life pressures. So when we're thinking about open jobs that can't be filled, those are people that we need to do things. Yet at the same time, we can't get folks in those spots. When we think about the aging demographic in the manufacturing space, those are people aging past without folks coming in to replace them. That's a big concern. When we think about declining hiring success, another way to look at that is there's more of us competing for the same labor. So we're bringing in those candidates less frequently. All of those are data points that allow us to think a little bit differently about what automation can be for us. The way that I like to simplify this as the non-technical person is I think too often when automation comes up, we think about it as an A to B solution. How do we make A to B better? How do we improve it? Or maybe it's C to D or M to N, wherever you're sitting inside that line. At the same time, what we're trying to argue is there's actually a case to think about it as A to Z. How do we think about the whole process by taking a step back? So many of our customers sit within the food and beverage space. Within the food and beverage space, some of the nuggets that really stand out as catalysts for change, 47% of food manufacturers said a lack of qualified candidates. We're not finding the people to do the work that we need. And that leads to people having to work more. 40% forced into overtime dynamics. So we're causing the same labor to work harder, to work longer, and to likely not produce the same level of efficiency within their roles. And the last component is 36% have stated that's caused a lack of production, right? Decrease in production. The marketing guy in me, is always how do we do more? How do we go up and to the right? So when all of a sudden we can't produce as much, it's a reason to think a little bit differently. On the age bucket, I think why this is so important, and maybe I'm also looking at myself in the mirror as I continue to age in this bucket, we're not replacing at the younger level the people that we need for folks that are getting to the retirement point of time. So I'm going to take a step back and jump into some of the academic stuff. I think we have all had those moments in our careers where an executive leaves you with a book and we say, do I actually want to read it? About 15 years ago, someone I was working for left, our iceberg is melting. And I'm like, why am I reading this? But I think this is a good lens to simply say how things are today can't be how they are tomorrow, or we won't be here. So a big portion of this, why it stands out to me, is John Cotter's lens into change management, really an 8-step process. So when I layered out some of those facts up front, there are things that we feel. At the same time, if we feel them, we're experiencing them. How do we use them as a group to be a catalyst for doing things differently? Piece that you see in the first 3 stages are really taking those realities, bringing them together, and laying out a strategy against it. So once again, too often automation can become A to B, rather than thinking about as a company, how do we bring it all together? So when you start to hear some of Spencer's examples, I want to think about this lens of going through change over an 8-part series of time and try to put it to life. So next up, when we think about what this starts to mean in production levels, we had a customer that was nice enough to lend us their new line in our West booth over in the other corner. I got to spend a lot of time with her. And one of the stories that really stood out was this example of how they have changed the way that they're doing their production level. And a big piece of this is not replacing talent, which is what operations we often think about within automation, that we're replacing one to another. Losing my voice. At the same time, when we think about that, it's not replacing the people, but it's using the people differently. So that's a big part of what we're thinking about. Where does the money start to go to? In a lot of ways, when it comes to the money, we're putting people in situations, we're investing in improvements in the production line. On top of that, it's not just what we think we want, but where people are investing dollars. So at this point in time, I want to give some real examples for Spencer to come up. Thank you, bud.
Yep. Thank you, Josh. So Josh has explained the why of automation, why we need it these days, and it's becoming more important. And we need to discuss how we should automate, because real value doesn't come from plugging machines into existing processes. It comes from rethinking operations altogether. And marketing has come up with this term, operational reimagination. It's just applying the engineering design process to your process, understanding the design constraints, the performance criteria, and doing it from a lens of the full system as opposed to just one action that needs to be automated. You need to think of it cohesively. So we need to rethink our workflows to align with the modern realities that Josh covered, some of those labor shortages and SKU complexities. And some people have done this by segmenting their production lines by SKU volume. So they take high throughput SKUs and receive dedicated automation investments for those first, and then move on to the more semi-manual and flexible operations. That allows you to make sure you're hitting the low-hanging fruit first. And then adaptability and changeover. A lot of people are running many SKUs, and then they have to change over between them, and that causes problems because it can be downtime. And with automation, equipment is spec'd for a certain range of dimensional tolerances and different packaging specifications. And you want to have adaptability to change over between different formats. And one thing you can do, it costs more, but you can automate your changeovers. And that can be accomplished through having motor-driven adjustments to certain machines, and so that all adjustments are made automatically. And that will allow you to have reduced time for your changeovers and can lead to a lot of savings and improved OEE as a result. Then packaging design. If you're not currently automating any of your SKUs or any of your production processes, your packages have just kind of organically evolved over time, often driven by marketing and what has worked for manual case packing purposes. But when you want to automate your whole system, you want to make sure that your packaging is aligned with the ways in which the automation equipment works. Certain formats are more lending to automation. Humans have the ability to package a variety of different formats, but once you want to do it at a high throughput, certain formats are better, and you want to optimize around those formats. We had a protein case packer that had six case styles, and they were able to consolidate into a single case packing format and had savings as a result of that. And then automation value. It extends beyond just the labor savings. People often think of the costs behind our existing labor as being just a value. Like $52,000 is what they often approximate for direct labor costs, but it's more than that. It's the cost of the reliability of the labor, the changeovers, and just the productivity loss you get from using manual labor. When you automate, you have more consistent, more reliable equipment. You do have to account for downtime, but the key thing is when you're proving out the automated solution, make sure you're taking into consideration the full costs of what you're currently doing, as well as the opportunity costs of what you're not doing and what you could be doing if you were automated. I'm going to skip that one and move to smart automation, which is about utilizing technology that currently exists to the fullest extent possible, and also leveraging AI in certain circumstances when it's beneficial, and we'll get to that. So smart automation, the key thing is if you're automating your front end and like product loading and you're automating the back end, like palletizing, you have to make sure that you don't bottleneck one side. So the system has to take into account all processes from start to finish to make sure that your OEE isn't compromised as a result of a certain operation. And one thing that helps with that is centralized line control. And it's very nice because traditionally, when you have multiple machines, they have different HMIs, perhaps different control systems. And if there's a fault and the line goes down, you have to look around for the machine that's got the red light, go over to it, figure out how to clear the alarm. With centralized line control, you can look at a single location, any location, you're looking at the same HMI, and it allows you to see exactly where the fault is, clear the fault as necessary. It just gives you more control over the whole process and allows you to be a bit smarter in terms of how you manage your equipment while it's operating. So as you evaluate your readiness for automation, it's important to consider those design constraints and performance criteria and balance them relative to what you're trying to do. And that comes with asking the right questions. First step in the engineering design process is define the problem. And that means that you have to ask yourselves what manual processes are currently repetitive or ergonomically risky or dangerous. And that's one of the great benefits of automation is you can automate those, and it has safety benefits as well as production throughput benefits. And when you look at your existing processes, some may not be well suited for automation in the way that they're currently handled. And I covered that with some of the packaging formats that aren't lending to automation. And then finally, you can evaluate your goals, labor savings, speed, consistency, safety. You don't need to compromise on any of these, but consider what it is that you want the equipment to do, and those are your performance criteria that you should strive to hit. The constraints, floor space constraints are often one of the largest things when it comes to automation. How do you fit all of this automated equipment with its electrical enclosures and conveyors into a single space that was previously just humans that were flexible? You need the layout, and you need to consider what's possible within that constraint. And you need to consider often, can we rearrange how we're currently doing things? Can we break down a wall if possible, if needed? And then also clearance and safety for the equipment that you have. So when you plan out your new layout, don't just place the CAD blocks into the existing layout. Consider door swings, access for maintenance, all of these things. And then you needed to understand your packaging specifications and product requirements. So this is just about understanding how the product arrives. So when you want to automate, the key thing is control. If you lose control on the product, then it's your system could jam, it can go down. You want to maintain control. So how does it currently arrive from, say, your oven? Is it in rows, or is it chaotic? Are people just dumping product out of a box onto a conveyor? If it's chaotic, your automation may need machine vision. If it's very structured, you could use something like row distribution with conveyors, which is a little more simple. The key thing is, if you have control of the product, don't lose control, because it takes effort to get the control back again. And this slide covers that as well, just the in-feed requirements and what it takes to manipulate the product in order to get it from how it arrives in the process to where it needs to go in the packaging process. And then multifunction automation. Yeah, today with robotic cells, that you can have versatile end-of-arm tools. So that allows you to have a single tool that can potentially adapt to accommodate multiple products. You get this with soft robotic grippers or palletizing end-of-arm tools that can lift both a full layer of products but also grab a slip sheet for the pallet. So you want to leverage the capacity of automation and dynamic design to allow yourselves to hit the fullest range of your SKU list so that you're optimized efficiently. And the whole thing is just, you're trying to automate, you're trying to move to the fully automated system. Everyone would love to have lights out manufacturing. To get there, you're not going to get there in a single step. What you want to do is take a single step and have it be at least in the right direction. So that you want to measure twice and cut once, and that's the whole idea, is have a blueprint and make a careful decision to move in the direction of the ideal solution. So now we'll get into some real examples that we've had. First one being syringe packaging. This was for a major medical device customer, and the challenge wasn't just the speed, the throughput, it was also precision and traceability. And we built a system that used Delta robots to pick the syringes from bins and route them to one of 3 flow wrappers. And along the way, they were scanned, and any defective products were automatically rejected. And then when it came to the pack out, they needed the flexibility of a manual pack out system, but they had a Poka-yoke system that allowed them to ensure that they always selected the right package for the product that they were packaging, and they used the right label. They could only access the label that was correct based off of the recipe that was set for production at that time. This is a meat processing line, and the goal was to make it as automated as possible. And we integrated everything from overwrap and bagging to automatic palletizing. And they were able to run 8 SKUs simultaneously. They had multiple mechanical palletizers running in parallel, and we would buffer the product and then send it a full pallet's worth at a time to an individual mechanical palletizer. And it just gave them full traceability, and they were able to this was greenfield, but they hit their performance targets and had a very reliable system based off the buffering and the traceability. And then finally, a bakery example. The customer made frozen fast food biscuits for a major chain, and the challenge was that the line didn't stop, and so we couldn't stop the packaging, and so we had a dual lane system, and that provided redundancy. And what that allowed for us to do is run both lines at 50% speed. If either side did go down, you could have the one side accommodate the full production until the other line was back up to speed. So that gave them operational flexibility and peace of mind. I'm going to cover a little bit about AI-enabled automation. Everyone's talking about AI and how you can use it. I'll discuss a couple of ways that we use it. One is vision inspection systems for quality control purposes, and also for bin picking purposes. It just allows you to better identify the product that you need to manipulate, and with quality control, it allows for a lot of certain inspections that we did with traditional vision libraries couldn't handle something like a package losing its vacuum seal, where AI-enabled vision allows you to do that. I'm just going to go into the closing thoughts now. So the most effective automation isn't off the shelf. It's designed and for your packaging process, and it comes down to understanding your performance criteria that you have currently, what it could be if you leveraged automation to the fullest extent possible, and then understanding your constraints that you have in terms of your current SKU list, in terms of your floor space, financial constraints as well. And the key thing is balancing all of those things and moving in the direction of a more efficient packaging system. Do you guys have any questions?